Lesson 4 is starting to get into the fun stuff now. We're going to talk about approaches, we're going to talk about clearance, we're going to look at some approach plates here as well. We're going to start off with a topic that's near and dear to my heart, and that's staying ahead of the airplane as well. Really working, especially in IFR flight, on some great ways we can start here on the ground to stay ahead of the airplane in the IFR environment. One of the first things you remember learning as a private pilot is how to stay organized in the cockpit. It's easier to stay ahead of the airplane that way, something we're always talking about. Well, this is even more important in your IFR training. During an IFR flight, you need to maintain not only situational awareness, you need to stay like 2 steps ahead of the airplane. When you're in the clouds, you're getting bumped around, it's easy to literally lose where you are in the flight, in space. I fly past that airport, what happens next? Who am I talking to? What is that radio call for me? When you're flying under IFR flight rules, you're going to have ATC telling you what to do a good part of the time. So they're giving you specific instructions. So knowing what they're saying, thinking ahead of them, it's all comes down to being organized, and it actually all starts on the ground. You've heard me say this a lot. I stay ahead of the airplane, do it all on the ground ahead of time, right? That's what this lesson is all about. It starts with even copying our clearance. Here's an acronym, if you haven't seen this before, that you're going to use throughout your IFR training. And I literally, 10,000 hours later, I wrote it down this morning for an IFR flight. CRAFT is the acronym. Every single IFR clearance, I still write down CRAFT because I'm just not good enough to memorize all of them if it's a long clearance. CRAFT, C-R-A-F-T. All clearances come in this specific order. It stands for cleared to, route, altitude, frequency, and transponder squawk code. That way you have everything there. Just to kind of go through this, where am I cleared to? 23 Mike Zulu is cleared to the Ocala Airport. My route, is it radar vectors? Is it a VOR? Is it a Victor Airway? They're going to give us all of that. My altitude, usually they give me an initial altitude and then a expect altitude. Climb, maintain 2,000, expect 10,010 minutes after departure. A frequency to talk to approach, 120.1. Finally, a squawk code, 1234 could be the squawk code. Make sure you write the clearance down. Now, the FAA doesn't care what medium you use to copy that down. I'm doing it on the iPad now. You could do it on pen and paper. It doesn't matter. All that matters is that you do copy the information down. So you can read back what you've written down to the controller and it is correct. So when that controller gives you that clearance, they're going to give you the magic words as well. Read back correct. If not, they're going to tell it to you again. You'll have to read back each part of it. So let's summarize here. Before takeoff, the controller, we'll talk about which controllers in a bit. Sometimes it's ground, sometimes there's a dedicated clearance delivery. But the controller gives you a departure clearance, an IFR clearance. We're going to write it down. Now you're going to be writing down a lot of things during the flight here as well. Headings, turn right to heading 250. So you got one hand on the yoke making that turn, the other one's writing that down. This is where an autopilot comes in handy, as you know. And if it's not busy enough, if you don't hear them, you might ask them to repeat those instructions as well here. So if you need that, that's always fine. Always ask for that clarification. But what I'm talking about here is what we actually read back. You'll hear through that CRAFT acronym the controller say read back correct. The read back is critical. Let's say the controller told you you're cleared for the ILS 17 approach, but you asked for the RNAV 17 approach, and you're told cleared for the ILS 17. And because you're so focused on the RNAV 17, all you just hear is that simple little 17, and you reply clear for the 17 approach. You better believe that a controller is going to come back asking you to repeat the clearance. They need to hear you say cleared for the ILS 17. At first, it might seem like the controllers are, just talking so fast, or maybe they sound frustrated with you. You know what? They're humans too, and there's a magic phrase you can say. Say again. Say again means, can you please repeat that? In a polite, short kind of code manner. The controller wants you to get it correct. They want you to have the correct information. So they will repeat the clearance to you here, just so you have all of that. So let's look here. Here's two pilots preparing for an IFR flight, getting the cockpit set up. The pilot on the left is using an iPad where we have any departure plates that we have, en route charts, approach plates, everything's digitally stored there. Now, all that's within a finger swipe, literally. You can make the print larger, whatever it takes. The pilot on the right is using paper charts. Paper charts are either produced by Jeppesen or what are called NOS charts, or government charts. It's important to pull out our charts, sometimes referred to as approach plates, that you need before each flight, and have them in the order you're going to use them. Have the plate you need for departure, then for approach, then for the airport of intended landing, then for the alternate, everything just in case, so you have it all there and ready for you. This is the RNAV GPS runway 36 approach at Ocala. Now, the information on both a Jeppesen or a NOS plate is the same. Both have inbound headings, altitudes, radio frequencies, and the like, but the presentation, as you can see, is slightly different. Jeppesen plates are available by subscription, and they're favored by many air carriers and flight schools. NOS charts are the government-produced publications and are available from most FBOs and pilot shops. My advice to you is pick one and stick with it, Jeppesen or NOS. It doesn't matter to me. I am still literally flying with the NOS government charts, although when I went to flight school, they had us using Jeppesen because many of the kids there along with me were on the airline fast track, and something that I never continued to pursue and went back to using NOS charts. Now, these plates have an expiration date on them. Always check that, please, before you intend to use them. If you intend to use them on the iPad, please make sure you know how to use it before you even get into the airplane. That includes searching for plates, approaches, using the notepad feature to copy your clearance. You want to be sure it's fully charged before each flight as well. You have the appropriate charging cable in case that iPad starts to run out of juice. It's so important to keep yourself organized. I know this was kind of a big overview in a way. We're going to take each of these little topics and break them down bit by bit in the upcoming videos. So the big difference between a VFR flight plan and an IFR flight plan is that to obtain that IFR flight plan, we actually get a clearance from ATC to fly the whole thing. As a VFR pilot, launching from a towered airport, you need permission to take off, traverse certain airspace, land, non-towered airport, even more open, right? Self-announced for the most part, what I like to call pilot-controlled airports. However, in the IFR environment, you need to have permission to take off no matter if you're at a towered or a non-towered airport, assuming, by the way, you're going to depart right into IFR conditions. We'll talk about some of those nuances in a little bit here, but this is called getting a clearance. When the conditions are IFR, whether you're flying from towered, pilot-controlled, that non-towered phrase, right? You have to get your clearance before the ground when the conditions are IFR at the airport, as I said here. So when the weather is below that required for VFR flight, or you're planning to fly on an IFR flight, we're going to grab that clearance on the ground. We learned about the clearances a video ago, and CRAFT as our acronym. Now let's learn where we get our clearance from. This is the clearance delivery frequency. This frequency is set aside at all Bravo, Charlie, and a few Class Delta airports have a clearance delivery frequency. Now you'll find this frequency in your chart supplement directory and on the printed information known as the departure procedures. This is actually the departure procedure from Orlando. If I can read and follow the directions, I should be able to fly this, but to do so, I legally need to have a clearance from the controlling agency. If the airport doesn't have clearance delivery, or maybe it's just not being used that day, you may be able to get your clearance on the ground frequency. Now on the ATIS, there may be a note, contact ground for departure clearances. If not, we can also use what's called a remote communications outlet, known as an RCO, or a ground communications outlet known as a GCO. There are even more RCOs and then GCOs. A GCO is actually over the phone, so it's through the phone. You literally key up a frequency, and it's going to sound crazy, but you'll actually hear it ringing over your radio. I'm talking in your headset, and someone will get you the clearance through your VHF radio. That's how that GCO works. Essentially, you are calling flight service. RCO, a little bit different, and there's more of those as we explained. RCO is VHF to VHF to the flight service station. You can find the frequencies. If the airport has an RCO, it's on the rectangular boxes of the VOR. The letter R tells you that there's an RCO, and that is the frequency. Another way to get your clearance is to contact the approach controller on the actual approach controller frequency. The challenge can be when you're still on the ground, that controller may or may not be able to hear you, or they may hear you, but you may not be able to hear them. You may have to actually take off, being careful to remain in VFR conditions until you can contact them to get your IFR clearance. Now, if the field is IFR, you're truly out of luck. You just cannot leave if the field is IFR and you have no way of obtaining your clearance. That is illegal. Even though you have a clearance or a flight plan on file, you need to pick it up and get cleared into those conditions. Let's look at the chart supplement for the Fort Myers area, as you can see here. Fort Myers, RCO, is a towered airport. When towers close, they have RCOs. If we contact Fort Myers RCO, we might say, Fort Myers RCO, Skyhawk 23 Mike Zulu, like to pick up IFR clearance to Ocala. Now, when they give you your clearance, it will be in the craft format. You can go ahead of the process. What I like to do is think ahead, write down craft vertically. A lot of the iPad apps have a craft scratch pad ready for you, and that way you're ready to write it down. We hear Skyhawk 23 Mike Zulu. It's cleared to Ocala Airport via Victor 441 to Gators, then direct. Altitude, climb and maintain 4,000, expect 5,000, 10 minutes after departure. Departure after departure. Departure frequency 118.6, squawk 5645. You then read all of that back to the controller. And if you get it right, you hear those magic words we talked about in the first video, read back correct. Those are magic words to hear. That means everything you read back is perfect. Then usually the controller is going to ask you to notify them when you're ready to taxi. And they do that sometimes. If it's clearance delivery, they're not. They're going to go on to the next clearance and you'll have to contact ground. If it's on ground, they may actually advise you of that just to say, hey, let me know when you're ready to taxi. But honestly, you're sitting down, you're getting everything programmed, you're getting the route programmed in the GPS, you're getting everything written down and ready, transponder squawk code in, you're thinking ahead of the airplane. But let's take a step further back from that when writing these clearances down and having to read them back. How can we think even further ahead of the airplane sitting on the ground? Can we pre-fill out the craft acronym to the best of our ability? For example, the C in craft, where am I going to be cleared to? Well, cleared to is easy. I know where I'm going. I'm going to OCF. I can write that down. What about the R, the route? Route can be a little bit tricky. In a perfect world, I want to write down as filed, a big AF, as filed is what I want to write down there. That doesn't always work out that well either. Sometimes you can look at websites like FlightAware that'll show you your route. Sometimes ForeFlight will project a route for you. Sometimes you can look at the preferred IFR routing list, but it depends on the day. Route is a 50-50 shot of you getting it right here. So what I typically do is hope for as filed, but I'm ready to copy down anything and spelling of those weird fixes they're going to actually give us there. My altitude. Well, I don't know my initial altitude. I hopefully know my final altitude, but one thing you'll notice is you're always told to expect an altitude. So you could write down an EX, climb maintain 4,000, expect 5,000, 10 minutes after departure. You could write down just EX to kind of separate the two altitudes so you know, and then write down the time there as well. As far as the departure frequency, you may know that, and you can look that up. I know in our area it's always 118.6, so I can pre-fill that. But the transponder squawk code, the T in the CRAFT acronym, that's just something we always have to wait for. Now, if you miss part of the clearance, ask the controller, just to say again, please. You know, that's pilot talk again for repeat that. The controller will not let you go until you've actually read back the clearance correctly here. Now, when operating out of a non-towered airport, you're going to get something extra. You're going to get something called a clearance void time. Because what a clearance does is it holds a block of space for you. Think of it like a table reservation at a restaurant. Only one airplane can be using the IFR system at a time at a non-towered airport, meaning only one aircraft can be coming in or going out on an IFR flight plan. So a clearance void time means that if you're not airborne and in contact with ATC by a particular time, that block of airspace will be given to another pilot. So in our next lesson, we'll take our knowledge of craft and apply it to instrument flying is all an exercise in following directions. These directions are given to us in the form of a clearance. A clearance consists of 5 things that we can remember. Remember, it's the CRAFT acronym. Where are we cleared to? It may be a fix, it may be an airport, it may be a VOR. We write it down. Next, the route, radar vectors, headings, altitudes, controller assigned, Victor Airways, a heading, a fix, a VOR. Write it down. Our A is for altitude. Most of the time, we're going to have several altitudes told to expect as well. The first one will be flying, followed by what we're to expect in 10 minutes. Next is our frequency, the first controlling agency we're going to talk to, and then T is the transponder squawk code. You'll be expected to repeat this and read it back to the controller. The term is read back. We want to hear those magic words, read back correct. Remember, I gave you the example earlier of what if I want to shoot the RNAV 17, but I get cleared for the ILS 17. All I hear is 17. The controller is going to ask me to say, no, I'm clear for the ILS 17. That'll give me an opportunity to say, no, I need the GPS or the RNAV 17. If you never understand a controller, magic words, say again. It's like saying, please repeat that. It's a magic phrase in that way. Now, let's talk about how we grab these clearances now and talk a little bit about those departure procedures. If the airport has an instrument approach, well, that's how we're going to get into the airport when the weather's IFR, but how do we actually depart it? We use a departure procedure. Now, with the departure procedure, there's obstacle departure procedures, standard instrument departures. So there are really 2 departure procedures actually used here. Obstacle departure procedures are sometimes called ODPs. They're based on the assumption that the departing aircraft will be less than 35 feet over the ground when it reaches the departure end. Be at least 35 feet over the ground when it reaches the departure end of the runway, and the aircraft is capable of a standard climb gradient of 200 feet per nautical mile. Remember that. 200 feet per nautical mile is a standard climb gradient. You will see that on a check ride. You will see that on a knowledge test. Now, if you see the letter T in a black triangle on a departure plate, that means you must climb faster than the 200 feet per nautical mile because there is an obstacle off the departure end of the runway. Sometimes it's known as the trouble T because if you ignore it, it could bring some trouble. The other type of instrument departure is the standard instrument departure, also known as a SID. Standard instrument departures were created for noise abatement procedures for the benefit of ATC. So to avoid noise over neighborhood and for the benefit of ATC and congestion here. The standard instrument departure, SIDs, depict routes and altitudes to fly. SIDs are always issued in a textual form. In order to fly a SID, that instrument departure, you must possess at least a textual description and have a clearance from ATC. To take it a step further, there are 2 types of SIDs, pilot navigation and vector SIDS. A pilot navigation SID is designed to allow you to provide your own navigation with a minimum of radio communication, keeping radio chatter down. A pilot nav SID usually provides an initial set of departure instructions followed by one or more transition routes. Vector SIDs usually require ATC to provide radar vectors, usually based on a climb of 400 feet above the end of the runway for making a turn until reaching the assigned route, fix, whatever it is shown on the SID. If your airplane cannot achieve the climb gradient to safely utilize the SID, you must put the words "no SID" into the flight plan remarks. So ATC knows that I just can't do that, and they have to come up with another option for you. If you do accept a SID, you must fly it as it is published, and it means you're making sure your aircraft can achieve the required climb gradient. Let's figure out how we determine the climb gradient rate of our airplane. When you see the letter T in the black triangle here, you know that you have to climb more expeditiously than 200 feet per nautical mile because there are obstacles in the vicinity. Let's say you're assigned a SID that requires a climb gradient of 300 feet per nautical mile and your ground speed is 90 knots. Find the 300 on the left side of the chart, then move to the right to the column with your ground speed of 90. And you'll see that we have a climb of 450 feet per minute. Well, simple math and using the chart there. So that's clearances. In our next session, we're going to learn more about the IFR en route system and the structure as we go through it.